So here we go with the tutorial on Lab 2 for t-tests. A lot of the work that you need to do this assignment happens before you start opening SPSS. You got to look through the assignment, figure out what kind of test to use, and then act appropriately. So I'm working from an example file that is not obviously the file that I'm asking you to work with. And so I'm looking at two scenarios here. The first one is a case, well, you can open the PDF and see. So in the first one, when I look at that, it looks to me like with one participant per line, those participants are both in the same two conditions. So this is going to end up being a paired t-test. And in my variable view, I'm going to need a variable for subject ID. And I'm going to need their puzzle solving number in the red condition and their puzzle solving number in the blue condition. Their subject ID is going to be nominal. Both of these are for the dependent measure, so they're going to be a scalar, which is ordinal, interval or ratio. That should be pretty much all I need. I don't think I need numbers for the values. So I can go here and enter my subject IDs 1 through 10. And my data, let's see. Looks good there. And in the blue condition, 15, 11, 17, 15, 10, 12, 16, 11, 12, 17. At this point, it would be a good idea to double check my, my data entries with some looking at the descriptives. You know how to do that when you need to. So I'm going to move on for now to conducting the t-test. So I'm going to go to Analyze, Compare Means, and then because I'm pretty sure from reading the study design that the same person was in two conditions, I'm going to choose a paired samples t-test. The paired variables are red and blue. This is going to show up blank, that's fine. There's nothing really you need to set under options. 95% is perfectly fine for alpha, and so you can hit OK. That will bring up your output. So the mean that you hand calculate should match the means that you see here. You should have the right number. You can take a quick glance at their standard deviations and make sure they're not wildly different. In this case, they're pretty good. Down here in your t-test, in your paired samples t-test, this is the average of the mean difference, the standard deviation of the mean difference, standard error of the mean difference. You don't really necessarily care about that stuff. You might care about the 95% confidence interval. You might want to glance and notice that in this case, that confidence interval does not contain 0. So that tells you that the null hypothesis of 0 difference lies outside this confidence interval, and that creates the expectation, sure enough, that our t-statistic is going to be pretty big. With 9 degrees of freedom, it is definitely less than 0.05 significance. So we're going to conclude that that is a significant difference. Okay. That's pretty much it for that first case. So now I'm going to move on to the second case. Go back to the other window and create a new SPSS data window. Now when I'm looking at my second case, the situation is a little bit different. I've got a data file where the description of the study suggests that people were assigned to one and only one condition, which suggests it's going to be a independent samples t-test. And so again, in my variable view, I'm going to have something like subject ID or participant ID. But now I need another variable to tell me what group people were in. Maybe I'll call it condition. And here it's going to be, were they in the diet group or the exercise group? And then I need their cholesterol level. That's the dependent measure. Cholesterol. Participant ID is nominal, condition is nominal, and cholesterol is scalar. Right. So here I go with my participant IDs. Okay, that looks pretty good. Condition, I see from my example that the first 9 are all in condition 1. and the next 9 are in condition 2. If I want to turn on value labels, I can click up here. That's cool. And then the dependent measure. Got 225, 229, 210, 222, 218, 205, 226, 225, 223. Checking now I'm in the exercise group. Good. 128, 220, 204, 218, 198, 213, 212, 207, and 205. Good. This time again, because I concluded that these individuals are only assigned to one condition and not the other, I'm going to go to Analyze, Compare Means, but choose a independent sample t-test. I don't know anything about the population mean or the population standard deviation, so I'm not going to do a z-test. Here I'm going to show that the test variable is cholesterol. Well, that's my dependent measure. And the grouping variable is condition. Now it shows these question marks here. That means it doesn't know what level of condition is what. I have to define groups. I'm going to say group 1, that's the one that we're going to put first in the equation, is the one that had value 1, and group 2 is the one that had value 2. If I had called these groups A and B earlier on in my variable view, then I would put A and B here. Okay. Here again, we don't really need to do anything fancy with the options. That's all fine. You can just hit OK. And this brings us up another t-test. Now this time, again, we have the means, so we can check that against hand calculations. We can check to make sure the variance here measured by standard deviations is not grossly off base. And down here you have the Levine's test for equality of variances. Again, this value is much bigger than 0.05, so that tells us, great, we don't need to worry about that. We can head on to T and the stuff that we're interested in. So here we have it observed T value of 2.677, 16 degrees of freedom, and here we get our significance, which again is less than 0.05, so we're going to conclude that there is a significant difference here. Once again, if you look at the confidence interval, you can notice that the 95% confidence interval for the difference does not contain 0. That's pretty much it. I do want to show you though, let's imagine that I go back to my data file, I do some other analysis that I don't really care about. Maybe for some reason, maybe you wanted to check the means, I don't know. You just do some analysis that later on you realize, okay, great, I did that, but Dr. Hall doesn't need to see that when I turn in. How do you get rid of extra output that you don't need here? All of the analyses that you do are listed here in this left bar. And if you click the sort of top level of them, you can select the whole thing. If you want to delete something, select it, and then you can go up to Edit, Delete, and that will get rid of it. And that way you can turn in nice, clean, efficient, non-tree killing lab reports that show me that you know exactly what you did and why. Lean is the goal. All right, that should do. Hope that helps.